Okay, good afternoon, gang. Our next session, Persistent Inactivity in Digital Media, Embedding Clickable Objects on Television Screen. This is presented by Toshiro. Okay.
Thank you, and good afternoon, everyone. My presentation is titled Persistent Interactivity in Digital Media, Embedding Clickable Objects on TV Screen Using Digital Watermarking Technology. Kind of a lengthy title, but idea is pretty simple, so let's get started. So this is about interactive videos, and interactive videos are really getting increasingly important, and it gives users more engagement or more personalized experience, and it will add items like entertainment and gaming essence to it. So what kind of interactive videos out there? It's like branching scenario. It's something like if you click something, and it will branch out to different scenarios. So depending on what you did, you will go through a different scenario. Or as you already know, this 360 degrees video is also popular. And there's a shoppable video and clickable video. These are the things that I'm going to talk about. Now, we made our prototype and demo last year out of one of the patent application that we made. And this is called a clickable objects. And this is made from a regular cooking show video. And if you click or touch one of the objects in the video, there's a pop-up window and it'll show more information about the product. And I'll show you how it works. So if you click the skillet, and it will tell you, show the window. You click the bottle, it's balsamic vinegar. If you click the plants, it will show you the plants. And this is a purchase information, and you can directly buy those products without leaving the video. It's pretty cool feature and great for e-commerce and product placement. And this is what's happening behind the scene. So as most of you are familiar with, this is object detection technology using YOLO VA for our demo. And each object is linked to a URL. So if you click, and it will jump to a URL, and the web page is shown in the separate window. So this is how it works. So you see all the rectangles that are detected objects. If you click inside one of these rectangles, it'll open up the web page of that particular product. So this has a lot of metadata required. So this page is HTML5 with the video in the background. And we need to have JavaScript, bunch of JavaScript code and CSS. And all the coordinates of each and every rectangles has to be preserved. Now, if you see this video on a computer screen or cell phone tablet, you can interact with your mouse or you can with your finger. But what if you encounter this video on an outside video billboard or TV in your living room? You cannot do anything because those devices don't have interactivity. You cannot click that object. And what you can do is you can just take out your cell phone out of your pocket and take a picture of video of this video. But you cannot really get more information directly from the video. You have to Google search and try to find the exact video to get more information out the product in the video. So the clickability is lost when you take a picture of the video. So what can we do about it? So here comes digital watermarking technology. So this is basically a technology to hide information in a signal. It could be audio, it could be image or video. And you can retrieve the hidden information after the signal is attacked. Attacked meaning for example, image or video, it could be resized or cropped or re-encoded or added noise. Even after those attacks, you can still retrieve the hidden information by decoding the watermark. So the main application for this technology has been like data security, copyright protection, and authenticity traceability. So, the Netflix is embedding something already in their content. Or if you go to a movie theater and take a shot of the movie with your camcorder, you might be traced. If you upload a video on your YouTube, for example, they can trace you, where you get the video and when, and things like that. So this is pretty, good technology, but, the application is limited to this area. So what can we do about this for our persistent interactivity? So this is how we do it. So we embed our metadata, some of the metadata for interactivity into a watermark. We embed the link URL to the original clickable video that I shown, just like invisible QR code. And if you capture this video on a camera and the image is sent to a decoder of the watermark, and then you will retrieve the URL and you can go to the actual original video. So the problem is the video has to go through these attacks if you shoot the video with a camera. So there's something called lens effect. That's a blur, compression, expansion, or distortion. And if you shoot this computer screen, there's a moire and a reflection problem. And if you're inside the room or outside, the illumination changes quite a bit, and that has to be treated as well. Also, the aspect ratio changes the aspect ratio of the display and your camera may not be the same. So some of the picture needs to be cropped. So that's another issue that we need to go through. So this is our approach. This is how we do it. So you have a original URL. Sorry, I missed the HTTPS portion, but the URL can be lengthy sometimes. So we can shorten the URL. It's well known, like tinyurl.com that we use. There are a bunch of other short URL methods that we can use. And then embed the string, which is only a character in this case, into a watermark. And display the watermark video image on a computer screen or television, or it can also be printed as a still image or on a paper or outside billboard. And then you can capture this image, watermarked image, with a camera. And then they send the captured image to an extractor. And then the extractor will extract the watermark. And then you can retrieve the watermark and get back the original URL for the clickable video. That's the approach we took. So here's how we found as a result, and what's here the result and findings. And for the watermarking algorithm, we tried a different watermarking technologies out there, and we have chosen it's called the Trust Mark, developed by Adobe Labs. And for some of you from Adobe, I'd like to thank you for that. It gives us a very good result, among other algorithm for the average extraction success rate in our environment. So extraction success rate is influenced by lighting condition and shooting angle, naturally. But we don't need to do a lot of things on the camera setting. Regular auto exposure feature on a cell phone or digital camera works fine. We tried the different shutter speed on aperture and everything, but we don't need to do a special setting for the shooting. Also, this is actually a video. Whoops. So this is a watermarked actual video, and you see some horizontal stripe or blur in around her face, and that's probably the artifact of watermarking. And you shoot the video with a camera, and the image below is the actual image taken by a camera, and this was sent to the algorithm, and we successfully retrieved the watermark from the video, for the video. So, like this, shooting an image from a video, or it could be a still image, if it's on the same screen, it doesn't make a difference on a success rate. So you can safely shoot the video and capture one of the frames in the video, and you can still retrieve the watermark. But there is some framing issue. I don't know. Okay. Framing issue means you can safely crop the video like this. So if you shoot about this area, and you can successfully retrieve the watermark. But if you try to cover everything in the image and include the items outside the image, for example, like a background or a taskbar or anything, and that will give you a pretty bad success rate. So those items are treated as noise, and so it's a noisy image, and then you cannot get the watermark back. So that's something that we need to think about. So what can we do? What is left to do for future work and improvement? So for the algorithm, the trademark algorithm gave us a pretty good success rate, but it's not 100%. So we are still looking for new algorithm, better algorithm for this particular application. And another one is localized watermark. So as you see in this video, I explained it to you. The watermark works like a invisible QR code. If you put QR code in every object in this picture, it's really annoying and distracting. But if there are invisible watermark, you don't see them. But you need to divide the picture into multiple areas and embed different watermark in each area. That is something we want to do, but we haven't found a good way to do that. So that's important improvement that we need to make. Another one is a faster processing. So for the QR code, you just put the camera and instantly you have a link appear on your camera screen. This is not there yet. We need to capture the image, send the image to a decoder, and wait for the watermark to come back. And we don't know if it's success or fail until we see the result. And it takes about 5 seconds on our environment. So if it's instantaneous, that will be a great improvement. Another one is automatic link assignment of detected objects. So we have to manually select and choose the link for each object, which is a lot of work. And actually, recently, Google Lens made that partially possible. But if you use Google Lens, something like Google Lens, it will give you a random link or some link that Google prefers and what Google wants you to click. So that's not really something that we want. So we need to have our own way of assigning the link semi-automatically. So, conclusion. So our prototype demonstrates that digital watermark extraction is feasible under a variety of conditions. But the success rate was influenced by lighting conditions, shooting angles, but the device type doesn't really matter. Whether it is a cell phone camera, it could be an expensive digital SLR, it doesn't matter. The regular cell phone camera with the default auto exposure is sufficient. And versatility extracting watermarks and video frames, still image on computer screen. So it could be video, it could be still image. The shooting images from the video is not really a difficult task for this prototype. And this algorithm towards cropped image, but it is sensitive to noise from inappropriate framing. So these findings underscore the robustness of watermark extraction process, but we still have an area of refinement. Okay, that's all for the presentation. Any questions? Yeah. Does anyone go there?
Thank you. One question.
Yep.
Do you have any plans to publish the raw data that you could draw your conclusions to, either for this first run or any subsequent more experimentation you're going to perform?
So we are an IP licensing company, and we filed some patent regarding this prototype. So if somebody is interested, and we contact us, and we will discuss how we can license, and then we will help you prioritize, but we don't develop products. Any other questions? Okay. Thank you very much.